we know from lessons at the beginning of the year that a relation is a pairing of input values and output values. Okay, that's a relation. And it doesn't matter how we get the outputs. All right. We could just say, all right, well, if you put a random input in, you get a random output back. You put 1 in, you get 2 back. You put 3 in, you get 4 back. It doesn't matter. Whatever you plug in, you have to be able to get something back. That would be a relation. An inverse relation exchanges or interchanges the inputs and outputs of the original. So what used to be the output for the original relation is now the input for the inverse relation, so on and so forth. So, for instance, if I had an input of 1 and 2 giving me an output of 2 and 4, then the inverse relation would be an input of 2 and 4 becoming an output of 1 and 2. So our numbers literally just flip around. What was in is now out. What was out is now in. If both the original and inverse functions or relations are functions, that is, they qualify the requirements for being a function, right? They've passed the horizontal line test. They don't repeat inputs, those kinds of things. Then the two functions are inverse functions. Now that's what we're really going to be concerned with, are inverse functions as opposed to inverse relations. But they kind of go together. Alright, so for instance, we can see here, just as an example, I have my original relation, and it's just a bunch of numbers, right? Inputs are my x values, 0, 1, 2, 3, and 4. My outputs, my y values, are 6, 4, 2, 0, and negative 2. And they're graphed here in blue. So those are my original relation as a graph. You can see my inverse relation. All I did was change the x values and the y values. So what used to be the y values in the original became the x values in the inverse. What used to be the x values in the original became the y values in the inverse. I literally just swapped x and y. I get a different set of points in that case. And what I'd like you to notice is that these points are these two relations are reflections of each other along the line y equals x. Right? This is the line y equals x, and all of my points are reflected from the original to the inverse on this line. So I have this point here in my original relation is reflected to this point here in my inverse relation. You can see they're reflected along this line. Ditto with this point here in my original is reflected to this point in my inverse. We could keep going. This point in my original reflected to this point in my inverse. This point in my original to this point in my inverse. So my inverse and my original have this reflection going on. Now that's all well and good, but we need to know how we're going to use this. And the way we're going to use this is by taking a function or a relation and finding the inverse. And it's really not all that complicated because it's mostly just solving equations. And we've been solving equations forever. Let's see how this works. Now we want to find an equation for the inverse of the relation y equals 7x minus 4. Right? So we want the inverse of this relation. It's really very simple. We know that the inverse is when we exchange x and y. So the first thing we want to do is exchange x and y. We're just going to flip it around. This becomes, instead of y equals 7x minus 4, x equals 7y minus 4. So you can see what happened. My y's and x switched places. That's all that happened. Now that I've done that, I want to solve for y. That's my next step. I want to solve for y. So I want to switch x and y. Then I want to solve for y. Those are my steps. Switch x and y, solve for y. To solve for y here, I start by adding 4. Now this is just solving equations, so we don't have to worry too much about this. I have 7y equals x plus 4. So I divide by 7. And I get y equals, I'm going to flip it around here, y equals 1 over 7x. I'll make that look a little bit nicer here. Y equals 1/7 x. Right? X divided by 7 is 1/7 x. Plus 4 over 7. This is my inverse relation. Y equals 1 over 7x plus 4 over 7. Done. Keep in mind, when we're talking about finding the inverse, we have a couple of things that we need to know. First, the inverse of the function is what we get when we swap x and y. Second, what we're doing is basically just solving for y. So, first thing we would want to do here is change this f of x to y, just so we know what we're looking at. So instead of f of x equals 4x squared, we have y equals 4x squared. So we want to swap, just like we did in the last video. We swap x and y, and we get x equals 4y squared. Now we want to solve this equation. To solve this equation, we would start by dividing by 4. So we divide by 4, we get 1/4 x equals y squared. Now we're solving for y, and y is squared. To undo squaring, we take the square root. So the square root and the square will cancel out. On the other side, we take the square root. The square root of 1/4 is 1/2. Square root of 1 is 1. Square root of 4 is 2, so that's 1 over 2. Since it's in an equation, it's positive or negative 1/2, because it could be either one. The square root of x is just the square root of x. So we have y equals plus or minus 1/2 square root of x. Now you might have noticed in our problem, x is less than or equal to 0. What that is what's called a restricted domain. That's telling me that when I'm setting up this function, the only x values that I'm going to look at are the negative ones, right? X is less than 0. So I can do that. I can specify, for this function, only look at -1, -2, -3, so on and so forth. Now, when we do that, it does have an effect. For instance, the domain of f in this case, right, the domain of the function f, is restricted to the negative values of x. What that means is the range of the inverse must also be restricted to negative values. And the reasoning behind that's a fairly simple one. As you know, for an inverse, the x's and the y's switch places. So that means that the domain and the range switch places, because the domain is x and the range is y. So the domain of the function f is the same thing as the range of the inverse of f, because domain and range switch places. So if one happens to be restricted, then the other also has to be restricted. Therefore, the inverse is f to the negative first of x. The inverse of x equals negative 1/2 square root of x. So that plus or minus that we had in our problem here, that plus or minus, became just minus. The reason being that the range has to be negative. So the plus or minus became minus. If the domain were restricted to the positive numbers, x is bigger than 0, then you would choose the inverse of f of x is positive 1/2 square root of x. So we chose either positive or negative based on this restriction of the domain.